Hey there, science fans! Today, we're diving into the fascinating world of stress analysis. Now, when I say stress, I'm not talking about deadlines or traffic jams, though those can certainly feel stressful. I'm talking about the force experienced by an object under pressure. Imagine squeezing a rubber ball. The force you apply creates stress within the ball's material. Stress analysis is like being a detective for objects under pressure. It helps us understand how forces distribute within a material and predict potential weak points. Whether it's a bridge holding tons of traffic or a paperclip holding a stack of papers, understanding stress is crucial for designing safe and reliable structures. Think of it like this. Every material has a certain strength, like a superhero's superpower. Stress analysis helps us figure out if the forces acting on an object will exceed its strength, potentially causing it to break or deform. It's like knowing if Superman can lift that heavy object without breaking a sweat. So, get ready to put on your analytical caps as we explore the ins and outs of stress analysis, uncovering the secrets of normal stress, shear stress, and the ever-important principal stresses. Let's go! Now let's break down the two main types of stress that engineers and scientists analyze: normal stress and shear stress. Picture a block of cheese being pressed on a cutting board. Normal stress is like pressing straight down on the cheese with your hand. It's a force applied perpendicular to the surface. This type of stress either tries to pull apart the material, tensile stress, or push it together, compressive stress. Shear stress, on the other hand, is like slicing the cheese with a knife. It's a force acting parallel to the surface, trying to make one part of the material slide past the other. Think of spreading butter on toast. That's shear stress in action. Understanding these two basic types of stress is crucial for analyzing how forces affect objects in the real world. From designing sturdy bridges to building skyscrapers that can withstand strong winds, knowing how to calculate and manage normal and shear stress is essential for creating safe and reliable structures. Hold on to your hats because we're about to explore a key concept in stress analysis: stress transformation. Imagine looking at our block of cheese from different angles. The amount of normal and shear stress we see changes depending on our viewpoint, right? That's where stress transformation equations come in. These handy formulas help us calculate the normal and shear stress on any plane within a material, no matter how it's oriented. It's like having X-ray vision for stress. These equations involve some trigonometry, but don't worry, they're not as scary as they sound. The main takeaway is that stress is not fixed. It changes depending on the plane we're looking at. This understanding is vital for analyzing complex structures and identifying potential weak points. Section 4. A cut at an angle. Calculating stresses on an inclined plane. Let's apply what we've learned with an example. Imagine a metal plate under tension, being pulled from both ends. Now, let's say we want to find the normal and shear stress on a plane inclined at a certain angle within the plate. Using our trusty stress transformation equations, we can plug in the known values: the tensile stress on the plate, and the angle of the inclined plane. After crunching some numbers, we get the normal and shear stress acting on that specific plane. This might sound complicated, but it's like using a map to find your way. The stress transformation equations are our map, guiding us to the stress values on any plane within the material. Pretty cool, right? Section 5. Finding the peaks, principal stresses, and their significance. Now let's talk about the VIPs of stress analysis: principal stresses. These are the maximum and minimum normal stresses that occur at specific planes within a material. Think of them as the peak and valley of stress. The cool thing about principal stresses is that at these specific planes, the shear stress magically disappears. It's like finding the eye of the storm where everything is calm. Knowing the principal stresses is super important because it helps us determine the maximum load a material can handle before it gives in. To find these principal stresses, we use something called Moore's circle. It's a graphical method that helps visualize and calculate principal stresses and their directions. It might sound intimidating, but it's a powerful tool that makes stress analysis a whole lot easier. Section 6. Wrapping it up. Key takeaways from the world of stress analysis. That was a whirlwind tour of stress analysis, but we covered a lot of ground. We learned about normal and shear stress, the dynamic duo of forces acting on materials. We explored stress transformation equations, our trusty tools for calculating stress on any plane, and we met the VIPs of stress analysis: principal stresses, revealing the maximum stress a material can handle. Remember, stress analysis is all about understanding how forces affect objects and predicting their behavior under pressure. Whether you're designing a skyscraper, a bridge, or even just a sturdy bookshelf, the principles we discussed today are essential for creating safe and reliable structures. So, keep exploring the fascinating world of science and remember, there's always something new to discover.